This video is for section 9.3 and it's going to be all about inscribed angles. Okay, again, we already defined what an inscribed angle was back in 9.1, but let's again define it now so that we remember what it is and then we can use it moving forward. Also, don't forget you're going to have a quiz after the next section, after section 9.4. Okay, so an inscribed angle is an angle with its vertex on the circle and with two sides that are chords. Okay, and what's going to happen here is an intercepted arc is the arc that lies between the endpoints of the inscribed angle. And the rule is that the degree of the inscribed angle is equal to 1/2 the measure of its intercepted arc. So again, I'll try to do matching colors here. So the first thing I'm going to highlight in this picture is the inscribed angle. Its vertex is on the circle and the two sides are chords in the circle. So in this picture, the measure of angle or angle ABC is your inscribed angle. The intercepted arc is the arc that lies between the two endpoints. So here's the two endpoints of the angle. There is the arc, so AC is the intercepted arc. So again, the rule is that the measure of this angle here is going to be 1/2 the measure of the intercepted arc. So let's just say that intercepted arc was 80, 1/2 of that would be 40. So the measure of your angle would be 40 there. Okay, so using what we just talked about, if the measure of angle ACB is 60, so if this is 60, now we want to find the measure of arc AB. Okay, so now we're going in the opposite direction. So the angle is 1/2 of the arc, which means if I want to go from the arc to the angle, we're not going to divide by 2 this time. We're going to multiply by 2. Again, look back up at this example. If I had 40 and 80, I would have to multiply 40 by 2 to get back up to that 80. So 60 times 2 is going to equal 120. So the measure of arc AB is going to be 120. Okay, and then for the second one, if the measure of the arc is 84, then we want to find the measure of the angle. So again, if we're given the measure of the arc and then we want to go for the angle, that's when we're going to divide by 2. So we'll do 84 divided by 2, and that will give us an answer of 42. So the measure of angle ACB is going to be 42. Okay, something else that's going to come up inside of this is going to be if an angle inscribed intercepts a diameter, then it's a right angle. So again, here's my inscribed angle. And again, here is, do a different color. Here is my diameter. Okay, so that angle is going to be, part of one side of it is going to be the diameter of that circle. That means that angle BAC, that means that this angle right here is going to be a right angle. So the measure of angle BAC is going to equal 90. Okay, so specifically in this section, if you are given a picture and you don't have any sides or other angles given, try to think back to this because that's usually what's going to end up coming up. Okay, and then the other thing that's going to come up inside here is if two inscribed angles intercept the same arc, then the angles are going to be equal. Okay, so in this case, angle ABD, this angle here is going to be equal to angle ACD, which is that angle there. Why? Because if I look at the arc that both of those intercept, again, directly opposite that, they both intercept that arc AD. Okay, so those two angles are going to be equal. So we want to find each angle measure here. So the first angle measure that I want to find is PQR. So again, look at that picture. I'm not given the measure of anything. This is what I was just saying like 30 seconds ago in that last slide. Hey, you're not given any measures. Think back to this. Okay, again, if an angle inscribed intercepts a diameter, then it's going to be a right angle. That's exactly what's going to happen in part A here. So PQR, again, here is your inscribed angle. PR is going to be your diameter, which means that that angle is going to be a right angle, which means that that is going to be 90 degrees. Okay, for part B, this time we do have measures of arcs that are given. So let's see what we can come up with here. We want to find angle RST. RST is going to be that angle right there. And then we also want to find angle RUT, which is going to be this angle right here. And just notice that the endpoints of both of those angles both intercept arc UT. So if somehow I can find arc UT, again, these two angles, the one that's highlighted in red and orange, are going to end up being congruent. Okay, I forgot also let's give that 75. Okay, so the entire circle is 365 degrees. And right now I have all the arcs of the circle except this one. So if I want to find arc RT, I'm going to add up all of those angle measures and set it equal to 360. So x plus 64 plus 139 plus 75 is going to equal 360. Okay. When you end up adding those all up together, and subtracting from 360, you're going to end up getting an answer of 82 in the end. I didn't write down what you get when you add together, but when you add together and subtract, so if you add all those numbers together and then subtract from 360, you're going to get an answer of 82. So that means that this arc is 82. So now again, if I want to find the angles, these angles are inscribed angles. So they're going to equal 1/2 the measure of the intercepted arc. And again, since they're intercepting the same arc, they're going to be congruent. So the measure of angle RST and the measure of angle RUT is going to be 1/2 of that 82. And 1/2 of 82 is 41. So both of those angle measures are both going to be 41. Okay, for part C, I want to find angle JKL. And again, angle JKL is this inscribed angle here. Again, inscribed angle would be 1/2 the intercepted arc. So again, if I can find the measure of this major arc right here, then that angle is going to be 1/2 the measure of that arc. So again, similar to what we did above, I can find that major arc by subtracting from 360. The entire circle is 360. I know this piece is 65. I know this piece is 53. So if I take out the 65 and the 53 that I've already used, it will leave me with that arc JMI. So when you do that, you're going to get an answer of 242. So that means this arc is going to be 242 degrees, which means now if I want to find the measure of the angle, again, the measure of that angle, the measure of angle JKL is going to equal 1/2 the measure of the intercepted arc, which is 242. And again, 1/2 of 242 is going to be 121. Okay, and again, just some other ways to look at these problems. Again, for part A, we want to solve for x here. Again, this is an inscribed angle, so it's going to be 1/2 of the intercepted arc. So again, I'm going to do 8x minus 9 equals 1/2 of 158. Half of 158 is going to be 79. So we're going to have 8x minus 9 equals 79. I'll add 9 to both sides, and 8x is going to equal 88. Divide both sides by 8, and x is going to equal 11. It only asks me to find x. I don't have to plug it back in or anything else. I'm done with that problem. Okay, and then for part B, they're telling me that this angle is 13x minus 1. Okay, and again, that's an inscribed angle. And again, it is intercepting this arc right here, which again, technically, I don't have anything written there. However, this is a diameter. So that means that purple arc is a semicircle, which means it's going to be 180 degrees. So that means the measure of that angle, the inscribed angle, 13x minus 1, is going to be 1/2 of 180 degrees, or 1/2 of 180 degrees is going to be 90. So 13x minus 1 is going to equal 90. I'll add 1 to both sides. 13x is going to equal 91. Divide both sides by 13, and x is going to equal 7. Only ask me to find x again. I'm done. Okay, and our last slide. In circle D, angle FTE is 21 degrees. The measure of angle MDG is 52 degrees. And arc TE is 86 degrees. And then we're going to find a bunch of different things here. Okay, so first let's put our givens into our picture here. So arc TE is 86. That takes care of that piece right there. The measure of angle FTE, that's this angle right here, is 21. And the measure of angle MDG is this angle right here, is 52 degrees. Okay, so now we're going to find a bunch of different things here. So the first thing that we have to find is FE. Okay, so arc FE is here. Okay, and that is going to be directly opposite this angle. Okay, and again, that is an inscribed angle. So again, the inscribed angle is 1/2 of the intercepted arc. Or if we're given the angle and we want to get to the arc, this is when we have to multiply by 2. So we'll do 21 times 2, which is 42. So the measure of FE is going to be 42. The measure of angle TME. TME is this angle right here. Okay, and that is directly opposite the arc that it intercepts is over here. That's directly opposite arc TE. So we're going to do 1/2 of 86 this time, and 1/2 of 86 is 43. Next thing I need to find is arc MG. MG is this arc right here. And now that is directly opposite this central angle, which is 52. And again, a central angle is equal to its intercepted arc, which means that if the central angle is 52, that means my arc is also going to be 52. MT. MT is going to be this arc right here. So I need to find arc MT, and what I'm going to do is try to highlight this in a different color so it might be easier to see. So this, what I'm highlighting in green right here, is the diameter. So this entire piece is going to be, again, a semicircle. So a semicircle has 180 degrees in it. I know that this is 86, so if I take my 180 and subtract out that 86 that I already used, it will leave me with just this piece right here, which is the MT that I'm looking for. So when you subtract out there, that's going to give me an answer of 94. Okay, I'm going to try to erase some things without erasing too much, just to make the picture a little bit clearer if I can. Okay, and again, we just found that this piece right here was 94. That might come into play. Okay. The next thing for part E that I need to find is the measure of angle TEM. Okay, TEM is going to be this angle right here. Again, that is an inscribed angle. Its vertex lies on the circle, and that's directly opposite my arc that I just found was 94. An inscribed angle is half the intercepted arc. So this is going to be 1/2 of 94. So if you take 94 and divide it by 2, you should get an answer of 47. So that angle is going to be 47 degrees. Next thing I need to find is arc GF. So GF is going to be this arc right here. Okay, now, as I look at that picture, I don't see an angle that is formed by the line segment that's over here and over here all together. Okay, so I'm probably going to have to use either the fact that something is going to add up to 180 or 360. So let's see what's going to come into play. Okay, back from part A, we found FE was 42, and we just found in part C, MG was 52. So there's my diameter of my circle, which means this is 1/2 of my circle, which is going to be 182. So if I want to find GF, I'm going to add up X plus 52 plus 42 to equal 180. Okay, or maybe an easier way to look at it is we're going to take 180 and we're going to get rid of the 52 and the 42 that we already used, which will leave us with GF. And when you subtract out 52 and 42 from 180, you should end up with an answer of 86. Okay, and then the last thing that we need to find, again, try to clean this up a little bit without erasing too much, because again, some of the stuff we're going to need. I need to find the measure of major arc MFT. So again, to find MFT, orange I think I can use, to find the measure of arc MFT, I'm following those arcs in order. So M, the letters in order, FT. Okay, so basically I almost went around the entire circle. The only part of the circle that I didn't go around was this 94. So the easiest thing probably to do is take the entire circle and get rid of that 94 that I don't want. So 360 minus 94 would equal 266. Hey, again, was that the only way to do that problem? Nope. We just found this was 86 in the last problem. So the other thing that I could have done is I could have added 52 plus 86 plus 42 plus 86. And if I did that, it would also give me that answer of 266. So again, there's not always just one right way to solve for these.